Hey guys, today we're looking at 4.3, which is all about dividing polynomials. So if you've noticed 4.2 between days 1 and day 2, we spent time focusing on how we can add two polynomials together, how we can subtract polynomials, and how we can multiply polynomials. So in 4.3, we're looking at how we divide polynomials, which dividing polynomials, it's like undoing multiplication, but it's not really factoring. It can be in a way, and that's something that we'll look at as we move forward in the class. But it's not really factoring. It's figuring out if something is a factor, but I'm really just dividing that one thing out of whatever I'm dividing. And I've got three different ways that I'll do this. I've got some basic basic division. I've got long division, and then something we'll call synthetic division. So basic division is when you're taking the polynomial and you're dividing it by a single term or a monomial. This is the nicest one because all we have to do in my fraction, if I'm dividing 9x squared plus 12x minus 18, if we're dividing it by 3x, because of how fractions work, if I'm taking something and dividing it by a single term, I can rewrite these as just three individual fractions. So I can rewrite this as 9x squared over 3x plus 12x over 3x minus 18 over 3x, and then just reduce within each of those individual parts. So here, my x squared and my x reduce, my 9 over 3 reduces to just a 3, so I end up with 3x for my first term. Here, my x's cancel out, top and bottom, and my 12 over 3 divides evenly into a positive 4. And then this last one, I don't have an x that cancels out, so I'm still going to have that x in my denominator. But here my 18 over 3 reduces to 6. So minus 6 over x. And that's it. That's my final answer. Basically what we're looking at here, it divides evenly 3x plus 4, and then I have a remainder here. That's that fraction that's left over on the right side. So we'll give another shot, something a little bit more complicated. With this next one, 5a squared b minus 15ab cubed plus 10a cubed b to the fourth. If we're dividing that by 5ab, we're again going to just start by separating that out. So 5a squared b over 5ab minus 15ab cubed over 5ab plus 10a cubed b to the fourth all over 5ab. And then again, within each term, I'm just going to reduce where it's possible. So here my b's cancel out, my 5's cancel out. A squared over a reduces to just a for this first term. Here my a's cancel out, my b's, 1 from the bottom cancels out with 1 from the top, so now that's a b squared. And then 15 over 5 reduces to a 3. So in total I've got minus 3b squared. And then for this last one, my a cancels out from the denominator to make that an a squared up top. My b makes this a b cubed. And then my 10 over 5 reduces to a 2. So plus 2a squared b cubed. So that one divides evenly. So something we'll talk about in a subsequent section, kind of with the second half of chapter 4 that we'll do in second semester. We'll say that since it divides evenly, there's no remainder. We just get nice whole number terms. That we would say that 5ab is a factor of that big nasty polynomial up top there. 5a squared b minus 15ab cubed plus 10a cubed b to the fourth. So that's if you have just a monomial that you're dividing by, just a single thing that you're dividing by. Now that doesn't work all the time because if you have something that's not just a monomial, we still have to be able to divide that thing. So when we do long division, like something bigger than a monomial we have to be able to divide by, like a binomial, which is going to be our most common one, which has two terms. I'm going to switch this back to blue. That's my standard color there. We know a binomial has two terms, right? Bicycle. We are going to start by doing long division, which I want to do a little quick refresher on long division first. Like basic long division that you learned like back in elementary school. If I wanted to divide 573 by 5, the process that we did this for long division was starting with what what I have to multiply this thing out in front here, this 5, by to make it match whatever that next term is. What I have to multiply by. So here, 5 times 1 would give me 5. I then switch my sign and go down. So I'm subtracting going down, so switch my sign and add it up. I have 0 left over. Then I'm going to drop that next term down. So now I have a 7. 7 goes in. 7 times 1 is the closest I can get. Gives me a 5. I have a remainder of 2. And then I drop that next term down. Is a 3. So now 5 times the closest thing that I would be able to get is times 4. Right? 5 times 4 is 20. Subtract going down, and I have 3 left over. I don't have anything else that I can drop down here, so this ended up being my remainder. So we would write this as 114 from that point, and 3/5 is how I would write that. If I was going to not say it's just a remainder of 3, but I wanted to put it as a fraction, I put it over what I was dividing by, 3/5. The same idea is what we're going to be doing for long division when it's a polynomial. So we're going to go through and try and figure out what I'd have to multiply this divisor by in order to get it to match up with that first term in what I'm dividing. And then eventually, as I go through and do that, if I have anything that's left over, that'll just be my remainder that I always write as a fraction of whatever that remainder was over what I was dividing by. So let's go ahead and jump into how we would actually do this problem using long division. So this 3x squared plus 7x minus 12 divided by x plus 3. So when I'm doing this, I'm going to set it up just like I did before with division. If I was dividing 3x, let's do this in blue, 3x squared plus 7x minus 12 is being divided by x plus 3. Now when I do this for long division, I'm focusing, when I'm trying to figure out what I have to multiply by to kind of go through each of these steps, I focus on just the leading terms. What do I have to multiply this leading term by in order to match the other leading term? So what I have to multiply x by to get it to match perfectly up with 3x squared. So in doing that, I'm going to actually just do this. In doing that, I would have to multiply x by 3x in order to get it to match perfectly. Right? 3x times x would give me 3x squared. So once I know what that is, then I take this 3x and distribute it into x plus 3. So 3x times x gives me a 3x squared. 3x times 3 gives me a positive 9x. So I figure out what that thing is up top by knowing what I have to multiply by in order to get to match. And then I'm going to go ahead and do that. Now from here, once I know what that is, the next step in long division would be subtracting, which I have to switch both of my signs in this case, because if I subtract, I have to distribute and subtract both of them. That should get rid of my first term here, which should always happen. And then over here, for my leftovers, 7x minus 9x gives me a negative 2x. And just like I did in long division, I'm going to then drop this next term down so I still have a binomial that I'm focusing on. So minus 12 here. And then I repeat the process over again. So now from this leading term and this leading term, what would I have to multiply x by in order to get it to match negative 2x? Well, we know that that would have to be, in this case, a negative 2 that I have to multiply by. If I did that, negative 2 times x is a negative 2x. Negative 2 times 3 is a negative 6. And we know, we have to subtract going down, just like we always do for long division. So here, if I subtract a negative, that's like adding, right? I have to switch the sign for both of them, and then add up going down. Those go away, and I have a negative 6 left over. Now, I don't have anything out here to drop down for the next layer, so that's where I end. That negative 6 is now my remainder. I always write it as a fraction with that up top and what I was dividing by as the denominator. So we can see here my answer would be 3x minus 2 minus 6 over x plus 3, which is exactly what we had before. 3x minus 2 minus 6 over x plus 3. So what you have to be careful of here, that's my final answer. And usually I would rewrite it up here. We could say minus 6 over x plus 3, however you want to do that. Indicate that that's your answer. Box it in, all that good stuff. What you have to be careful of, and I didn't have that in this problem, but in this second example that we're going to do, I have to make sure when I'm doing long division, every degree in my polynomial has to be represented. And what I mean by that is, if my highest degree is an x squared in this case, I have to make sure I also have x to the first power and my constant represented in long division in order for those like terms to add up. So when I write this next problem, I'm dividing 5x squared plus 0x plus 2. And I'm dividing that by x plus 1. I'm going to scoot this down just a little bit. Give myself some more room. All right. So again, I'm focusing on first term with first term. But what I have to multiply x by to get it to be 5x squared, which is 5x. If I did that, 5x times x gives me my 5x squared. 5x times 1 gives me 5x. So I'm going to go ahead and subtract going down because I have to switch that sign. That gives me nothing for that first term. Negative 5x for the second one, because 0 minus 5x is negative 5x. I drop this 2 down to make it a plus 2, and then I repeat the process over again. I look at first term to first term. What would I have to multiply x by to get it to be negative 5x? Well, in this case, of course, it's negative 5. Negative 5 times x is negative 5x. Negative 5 times 1 is negative 5. So as I finish up the problem here, I've got to switch my sign before I add up going down, and I have a remainder of 7 in this case. So my answer would be 5x minus 5 plus 7 over x plus 1. And that would be my final answer. Not the nicest thing in the world, but not the most crazy difficult stuff. It can be very tedious and time-consuming at times because we have to write out every single term, and kind of keeping track of where things are is not the nicest. But to kind of combat that, to accelerate the process a little bit, we have this thing called synthetic division that is a shortcut for long division that allows us to kind of bypass having to deal with all the different variables that we deal with. So in synthetic division, I've got all of the steps here in order of what we should be doing, making sure, again, here we have to put in any zeros for missing terms again. But what we're doing, and for synthetic division, we don't focus on the variables at all with the degrees and everything, because if you looked at this, the way that it always ended up happening was it's all based on like coefficients. The variables themselves don't really matter. My answer that I ended up with was always just 1 degree less than what I started with. Right, so I started with a squared here, and I ended up with an x to the first term. Here, again, I started with a squared, and I ended up with an x to the first term. That's always going to be the case. So with synthetic division, what we do is, again, just focus in on my coefficients, just those numbers that are attached to my variable terms. And to do that, we also are going to use kind of a little trick, and I'll show you how it works in just a second. But what we have to do for what we're dividing by has to be, first off, it has to be a binomial. This only works if it's a binomial, and it only works if it's set up as just x, or your variable, minus an r value, which means you could have x plus something. You just have to know that that r value means that it's just negative. But it only works if what you're dividing by is just x for the first term. Okay. So when we're going through and dividing by x minus r, we're going to go ahead and write down our coefficients. Bring our first coefficient right across the board. And here, this is the structure that I always have set up for it. You can see kind of the box frame that I have for it. So I'm going to start by just writing out my coefficients. So here, I've got x cubed, x squared, x, and then a constant. So I'm not missing any terms, but I'm just going to focus on the coefficients themselves. So I've got 2, negative 13, 26, and then 24. So those are my coefficients. I'm just going to write those across the board. And then up here in this box, I'm going to put my r value, which in this case, since I'm dividing by x minus 4, up in this box is just a positive 4. Okay, just a positive 4. So what I do now, this is kind of the synthetic part of it. This first coefficient, I just drop that straight down. It's always going to be the exact same thing for what I started with. I'm just going to drop it straight down. That 2 is still going to be a 2. But from here, this is where I start using that r value. What I'm going to be doing now is to get this term that I'm highlighting here, this empty spot here in yellow, I get that from multiplying the previous coefficient down here with what's inside my box. So I do r times that number to get my next term. So to get that, 4 times 2 gives me 8. And then just like I would do in long division, I just add up going down. So negative 13 plus 8 gives me a negative 5. And I repeat the process over again. 4 times negative 5 gives me a negative 20. Add them up and I get 6. 4 times 6 is 24. Add them up and they get 0. Now that last term there, that's my remainder. Because that last term is always going to be after my constant. Because if we started with a cubic, we started with an x cubed, this 2, as I write out my answer that I'll do here in red, this 2 becomes x squared, 1 degree less than what I started with. This negative 5 is my x term then. My 6 is my constant. And I don't have any remainder. I have a remainder of 0, so 0 over x minus 4 would just be 0, so I'm not going to write it. My answer, because I ended up with a remainder of 0, is just 2x squared minus 5x plus 6. It evenly divides. And that's what synthetic looks like. We'll do a couple more examples together just so you get a feel for it, because it is very weird. But once you get a hang of once you get the feel for it and once you get the hang of it, it is so much faster than doing long division. All right, so x cubed minus 2x squared minus 25x plus 6. I don't have any missing terms in there, so we're going to go ahead and just write out my coefficients. 1, negative 2, negative 25, positive 6. My r value, again, is positive 6 now because I was doing x minus 6. So synthetic-wise, drop my first term down is a 1, and then I start multiplying. 6 times 1 is 6. Negative 2 plus 6 is 4. 6 times 4 is 24, which adds up to negative 1. 6 times negative 1 is negative 6, which adds up to 0. We've got another one that has a remainder of 0, so it divides evenly. And my final answer would be 1x squared, or just x squared, plus 4x minus 1. My remainder is 0. And again, I know that those coefficients are going to be x squared, x, and the constant, because I started with an x cubed, which means my answer is going to be just 1 degree less than that. So it's going to start as an x squared instead of an x cubed. All right, one more here for us. And this one's going to be a more complicated one because it's A, more terms, and B is going to have a remainder. C, it's also missing terms. So here we notice that I don't have an x cubed value in there. I go from x to the 4th to x squared to x and to my constant. So when I write out my coefficients, I have to put in a 1 for my x to the 4th, a 0 for my x cubed, negative 10x squared, negative 2x, and then positive 4. The other messy thing here is that my r value, since it has to be x minus r, r would have to be negative 3 in this case because I see it as x plus 3. So having to switch that sign is another thing you have to make sure you just keep a track of. Now that we have that all set up, same process, I drop it down is a 1, times negative 3 is negative 3, add them up is negative 3, positive 9, right, negative 3 times negative 3, positive 9. Negative 10 plus 9 is a negative 1, which adds up, or multiplies to get positive 3, adds up to a 1, which is a negative 3, which adds up to a 1. So we do have a remainder in this case. Since we started with x to the 4th power for our original degree of what we were dividing, we end up with 1x cubed minus 3x squared minus 1x plus 1 plus 1 over x plus 3, because that would be my remainder. Again, whatever that remainder is, that's just your numerator over what you're originally dividing by. And then here, you don't necessarily have to keep those ones in there for the coefficients on x cubed or x. I just put them in there to make sure we emphasize and see where that connection is coming from. But that's it. That is synthetic division. That's everything for 4.3. Your homework is page 177, 6 through 24 evens. If you have made it through the video this far, you obviously are doing what you're supposed to do. On Monday, you are supposed to have watched this already, because I assigned this for you guys. I gave this to you on Wednesday, going into Thanksgiving break. So as a little extra treat for those of you who have been watching the videos when you are supposed to be watching the videos. On Monday morning or afternoon, depending on what class period you're in, when I ask if anyone has any questions about the 4.3 notes based on the video, I say, all right, anyone got any questions on 4.3 notes or from the homework? I want you, you're going to have your camera on, and you're going to have your microphone turned on. When I ask that question, I want you to gobble like a turkey. Gobble like a turkey. If you do that, if you gobble like a turkey when I ask, hey, anyone have any questions on the 4.3 notes, I will give you an extra credit point. You can choose to take it either on your quiz that Friday, or you can choose to keep it, and I will let you have an extra credit point on the final exam. So that is your choice. But again, when I ask the question, does anyone have any questions on the 4.3 notes, you have to go, and I will give you an extra credit point. I don't care how many people do it. If it's just you, if it's all 6 of you in that class, in this class period that gobble like a turkey, I will give you guys an extra point either on the chapter 4 quiz or on the final exam. But if you are watching this after the fact and you have realized that you should have watched this beforehand, sucks to suck. That is why I'm rewarding the people who are watching it when they're supposed to be watching it. So next time, maybe you watch it before you're supposed to, and you'll have the opportunity for some extra credit. Maybe. Who knows? As always, if you have any questions, concerns, thoughts, ideas, hopes, or dreams, make sure you guys are reaching out and letting me know. And have a fantastic Thanksgiving. Have a fantastic day, and I will see you guys soon.